All right. Um, so now it's just finding the domain and range of each. So for this first one, it is a straight line. It's going to be a diagonal. You can graph it in your graphing calculator. So our domain of this is it's negative infinity to positive infinity for all real numbers. And then range is the same, negative infinity to positive infinity. Again, all real numbers. So that's our domain and range of f. Okay, now to find the inverse, remember we have to flip-flop x and y. So it's going to be x equals negative y plus 2 and solve for y. So subtract 2. So it's going to be x minus 2 equals negative y, divide by negative 1. So our inverse is y equals negative x plus 2. Hey, check that out. It's the exact same as the original. So that is actually the domain and range of the inverse as well. Negative infinity to positive infinity for both. For question 6 here, the domain and range of this, again, is a line. So it's negative infinity to positive infinity for both the domain and the range. Flip-flop the x and the y, so it's x equals negative 8y minus 3. So here we can add the 3, so we'll have x plus 3 equals negative 8y, divide by negative 8. So y equals x plus 3 divided by negative 8. So that is our inverse function, x plus 3 over negative 8. And the domain and range of our inverse, if I graph it, you'll get another straight line. It will just be a lot less steep as the original. So that domain will also be negative infinity to positive infinity. Okay? So I get what you guys are probably thinking right now. You're probably like, okay, so domain and range is going to be the same for my function and my inverse function, and that is incorrect. In this case, it works out that way because of the type of graphs they create. However, here, it's going to be a little bit different. So for 7, first let's find the domain and range of that graph. So we're going to have to graph it. Let me get this over here. So it's going to be 2 plus the square root, negative 2 divided by x plus 1 plus 1. So let's go to Desmos here. Let me clear ink. Yes. Alright, so it's y equals negative, parentheses, 2 divided by x plus 1. Close the parentheses and then plus 1, right? Plus 1. Close that because I don't need that one and it's looking confusing. Alright, so here we go. Here's my graph. Notice, once again, we have another vertical asymptote. But here it looks like we also have a horizontal asymptote of this, what looks to be positive 1 here. It's approaching it, but it's never going to equal it, as you can see as I go further and further this way. It's getting a lot closer to 1, but it's never going to equal it. So this domain of this graph will be negative infinity to negative 1, because that's our vertical asymptote. So it's negative infinity to negative 1, and then negative 1 to positive infinity, which I will show you here. So yeah, domain of our original function is negative infinity, that's a negative 8, goodness, negative infinity to negative 1, And notice I'm putting a parenthesis, not a bracket, because I don't want to include it. And then it's also going to be -1 to positive infinity. Because reading it from left to right, it will encompass every x value except -1. And then our range is -infinity to +1. Again, not a bracket there because I'm not including that. And then +1 to positive infinity. So that's the domain and range of f. So now let's find the inverse. Again, that's flip-flopping everything. So we're going to have x equals -2 over y plus 1 plus 1. Subtract the 1. So we'll have x minus 1 equals -2 over y plus 1. We're going to have to multiply everything by y plus 1. Feel at this point I should have picked a different problem. So y plus 1 times x plus 1 is, I'm going to continue this here, is going to be xy plus -1y plus 1x minus 1. And then we have that equals -2. So what we'll have to do is we'll have to move our, notice once again we have two terms with y. So we're going to have to get both of those terms on the left hand side by themselves. So we'll have to add the 1 over and then also subtract the 1x. So we'll have xy plus a -1y equals -2 plus 1 is -1 and then minus 1x. And since we have two y's here, I can factor out a y, leaving me with x minus 1. So y times x minus 1 equals -1 minus 1x. And then to solve for y, I have to divide everything by x minus 1. So my inverse function here is y equals -1 minus 1x all over x minus 1. And now I could go through, graph it, and come up with the domain and range that way. Or I can use the rule I know about domain and range of inverse functions. The domain is going to be -infinity to +1 and +1 to infinity, and the range is going to be -infinity to -1 and then -1 to infinity. I'm going to let you look and think of how I maybe came up with that without graphing it. If you can't think about it, I will show you after this next example. So for this function, our domain is going to be -1 to infinity, and that's including -1. And our range is going to be 1 to positive infinity. And you could graph it and figure it out that way. And so let's find the inverse. So it's going to be x equals the square root of y plus 1 plus 1, subtract the 1, x minus 1 equals square root of y plus 1, square both sides. We have x minus 1 squared equals y plus 1. I'm going to subtract the 1, so we have x minus 1 squared equals, x minus 1 squared minus 1 equals y. Alright, so with this, so my inverse function is y equals x minus 1 squared minus 1. My domain is 1 to infinity, and my range is -1 to infinity. Sorry, that should be a bracket. Yeah. So that would be your inverse function there. If you have questions, please make sure you bring it in and we can discuss that tomorrow. And like I said, you're getting your domain and range because it is the domain of f is the range of your inverse, and the range of f is the domain of your inverse. That's how you come up with that. That's the trick.